The last transformation that we're going to deal with is going to be rotations. So it's kind of like when we're turning a figure around a specific point. So at the end, we should be able to define a rotation, identify the degrees, center, and direction, perform a rotation on the coordinate plane, and understand the difference between a counterclockwise rotation and a clockwise rotation. All right, this part is probably going to be the most confusing part, and I'm going to try to save that to the end and come back to it after I show you how to use all the formulas first. All right, so a rotation is a transformation that turns a figure around a point. Okay, descriptions of transformations involve three different pieces of information. So those are the three things, those are the next three vocabulary words. Two things to note. One, a rotation is definitely a rigid motion, and this one preserves orientation, unlike a reflection. So I told you I would go over this to show you what the difference is. So if I start with a triangle A, B, C, and I have this point here, and let's just say I rotate it, so I'm going to turn it over here, and it'll look something like this. So a better idea of orientation is that A, B, C is in this order here, going clockwise. And if I start at A again, and I go in that same direction, I still get the same three letters in the same order. With the reflection, that doesn't happen. So just remember, a rotation is a rigid motion and it preserves orientation. So the degree of rotation, our second vocabulary word, or for example, the first part of the rotation is just how far, how many degrees. So we're going to see 3 to 4 different degrees. We're really going to see 90 degrees, 180 degrees, 270 degrees, and 360 degrees. This one we probably won't see that much. These are the big three. All right, next is the direction. So there's only two directions we can go in. We can go in a counterclockwise direction, which is the main one. This is all the formulas are counterclockwise, okay? Or we could go when we get a star, we could possibly go in a clockwise direction. This one, the clockwise direction ones are a little different. It's a little special. It's got a little kind of thing that we have to work on, and that's the one that you have to be careful of. All right, the center of rotation, that's actually going to be the point that we rotate around. So the point the object is rotated around. So, for example here, a rotation usually looks like this. So capital R tells me it's a rotation. This is my center of rotation. And in this video, this is a O, it's going to be the origin for pretty much this entire video. So on all the coordinates, we're going to rotate around the center of the graph, the origin. I'll show you later on in this unit, we can rotate around different points, but for right now, we're going to assume that we're always going to rotate around the origin. All right, so this is the notation. It has capital R, which means rotation. It has the O, which tells us the center, and it has the degree measure that tells us how many degrees we're going to rotate. Now the direction we're going to talk about on the next page. All right, so here are the rules. When we rotate, we always go in order of the quadrants unless told otherwise. Okay, that means that we are always going counterclockwise with all of the formulas. Okay, so all of these formulas over here are going to go counterclockwise because the order of the quadrant is counterclockwise. So counterclockwise. And if the degree measurement is negative, then we're only going to rotate clockwise if that happens. And I'll explain how to do that at the end of the video. All right, I'll actually scroll through the packet and I'll show you an example. All right, so here are the four formulas. Here are the four formulas that you need to know. These are all counterclockwise rotations with positive degrees. So if the question just tells you to rotate a figure 90 degrees, use one of these formulas, okay, or use the correct formula. All right, so that's what we're going to focus on. I'm going to show you how to use these three of these formulas here in some 3 examples, and then we'll come back and we'll talk about when it's counterclockwise, when it's clockwise, and things like that. So first, rotate point P 90 degrees. So 90 degrees, since it just says 90 degrees, we know that it's counterclockwise. So I'm going to use this formula right here, okay? So if you look, the point xy becomes the point negative yx. So I'm going to switch the order of these 2 points, and I'm going to change the sign of the y value, so the negative 2. So the negative 2 is going to become a positive 2, and I'm going to switch to the front, and then the 3 stays the same. That's a rotation of 90 degrees. Now you can also think about a rotation of 90 degrees, it's going to move 1 quadrant. Okay, so if I start here at P prime, I'm going to move 1 quadrant, so that means I should wind up somewhere in this quadrant, which I'm going to, because if I plot the point 2, 3, here's P prime. I got that from this formula up here. Okay, so let's look at the second one here, rotate point K 180 degrees. So again, 180 degrees, it doesn't tell me which direction, so that tells me it's definitely counterclockwise, which tells me I can use this formula right here. So if you look at this formula, X and Y stay in the same order, and the difference is I change the sign of both of them. Okay, so I'm going to change whatever X is, I'm going to change its sign. Whatever Y is, I'm going to change its sign. So negative 3, negative 4 is going to become positive 3, positive 4. And if I graph it, it winds up over here. And again, 180 degrees, you can think of your point moving 2 quadrants. So if you look, it started here, moved 1 quadrant, 2 quadrants. So this would be a 90 and then a 180. All right. The last formula is going to be the 270 degree rotation. Again, it doesn't specify what direction, so if it doesn't specify, that means I can use my formulas. So this is a counterclockwise rotation, 270 degrees. And if you look, I'm going to change the sign of the x value and switch the order. So I start with 1, 3. I'm going to change the 1 to a negative, and then I'm going to switch the order. So A prime is going to be 3, negative 1. And again, if 90 was 1 quadrant, 180 was 2 quadrants, then 270 is going to be 3 quadrants. So started here. So I'm going to go 1 quadrant, 2 quadrant, 3 quadrants. So this is where my point should wind up. It should wind up over here if I did my formula correctly. So if I go to 3, negative 1, that's K prime. I definitely did my formula correctly. It moved 3 quadrants counterclockwise. So I know that that's kind of my final standing point. All right. So these are the formulas that you need to memorize. All right. These guys over here. And just remember, these are all counterclockwise rotations. Okay. So let's look at one more example, and then I'll get more into kind of what you need to do when it says clockwise. So graph ABC with vertices 2, 0, 4, 0, 4, 3. So let's start by graphing that. 2, 0 is A, 4, 0 is B, and C is 4, 3. And this says go in a clockwise direction of 180 degrees. So we're going to start the same way. I always like to start when I do transformations. I'm going to list out my points. And now the key thing here, so 180 degrees is special. It doesn't matter which direction we go in, because 180 degrees is halfway, or it's 2 quadrants. So it doesn't matter if we go counterclockwise, we're still going to wind up down here, or if we go clockwise, we're still going to wind up down here. So 180 degrees is special. It doesn't matter what direction you go in, the formula stays the same. All right, so the formula for 180, if I scroll back up, is change the sign of both coordinates, or of the x and the y coordinate. So here I'm just going to change the sign of all of these. So 2, 0 becomes negative 2, 0. 4, 0 becomes negative 4, 0. And 4, 3 becomes negative 4, negative 3. And I can plot my points from here. A prime, B prime, C prime. So there's my new triangle after it's been rotated 180 degrees in a clockwise direction. All right, so now here's the trick. So here's the big difference between clockwise and counterclockwise. Okay, all of our formulas. So I'm going to scroll up. We're going to put a couple notes up here. All of these formulas, as I told you, are counterclockwise. So clockwise formulas are the same The only worry is which one do you use? So, for example, if the question asks for a 90 degrees clockwise rotation, so meaning it's backwards, you cannot use this formula. So a 90-degree clockwise rotation, you are actually going to use the counterclockwise 270 because they are opposites one another. That's how this works. So if you're asking for a 270 degrees clockwise rotation, you would use the formula for a counterclockwise of 90 degrees. And we'll go over this together as a class because I think this is the toughest part for people to grasp here with this. But the big thing that you need to take away from this video is please memorize these 4 formulas, right? It doesn't matter if you understand clockwise or counterclockwise. If you don't know the 4 formulas and you don't know that they're clockwise rotations and you can't do these points, then it doesn't really matter what direction I tell you to do. So please make sure we have these formulas memorized. All right, please feel free, add some questions, give yourself a summary, and get started on the practice packet. And at the end of this video, we're going to have a mastery check as well. All right, so that's it. These are the 3 transformations you need to know. We did reflections, translations, rotations. Now we're going to get some practice with them, and we're going to bring it all together within the last 2 videos.